Okay, now we're going to go ahead and talk about Chapter 4. In Chapter 4, we start dealing with linear equations and inequalities of two variables. The first part of Chapter 4, 4.1, is going to be graphing linear equations in two variables. In particular, just working with lines. This will be our first chance to really understand graphs a little bit. The first place we need to start off is what are we going to be graphing on, and we call pretty much our sheet of paper the rectangular coordinate system, and we typically like to set it up like this all the time. This is pretty standard notation, so it's very important for you guys to get familiar with this. We draw two axes like this. The vertical one is going to always be the y-axis. The horizontal is going to always be the x-axis. And you can see that the x and y, when they make this crisscross, that we have four distinct sections that are bound by these axes. And we break these, we call these four things quadrants, and we always start with the first quadrant right here where x and y are both positive, and then we go counterclockwise. Second quadrant is going to be right here, third quadrant down on the bottom, fourth quadrant underneath the first, but it's always 1, 2, 3, and 4. It's very important that you remember that. Right at the point where x and y axes cross is going to be called the origin. In the rectangular coordinate system, the basic place we can start off with a graph is to actually plot a point, and a point is just going to be an ordered pair of two particular coordinates, an x and a y coordinate. You can see here that if I asked you to plot the point 3, 5, the 3 is going to always be the x, the 5 is going to be the y. So the x is always first and then the y. So just remember that. And here's a little note right here in the text, that when you plot points, x first, then y, okay? So if we were to plot the point 3, 5, we would go 3 units to the right and then 5 units up. If we look at the point 4, negative 3, that's 4 units to the right, 3 units down because this is negative 3 in the y. If we have negative 2, negative 7, that's negative 2 left because we got a negative 2 in the x and a negative 7 in the y, so negative 7 down, 7 units down. And if we, of course, plot 0, 0, we stay at the origin. That's the coordinate of the origin. Again, here are just some examples of plotting some points. 3, 2 and negative 2, 4. 3, 2, we always, like I said, this direction is positive x, this is positive y, negative x, negative y. So when we have 3, 2, we know this is the x coordinate, this is the y coordinate. So we go 3 in the x, 2 in the y. If we plot negative 2, negative 4, we know we go negative 2 in the x, negative 4 in the y. Now we're going to look at something a little more involved. We're going to be graphing an equation with two variables. The two variables in this case are going to be y and x. And when we see an equation like this, we should get familiar with it being a line. And a line is pretty much a set of solutions to the equation. What that means is there are many x's and corresponding y's that will satisfy this equation. And we can go ahead and we'll talk more about that in a little bit. But what we can see is if you have an example like y is equal to 2x plus 6, and they give us an ordered pair or a coordinate of 1.8, is this a solution of this? Well, graphically speaking, all that's asking is this point on this line? So we can learn how to graph this line and see if this point's on there. If it is, then it's a solution. If it's not on the line, then it's not a solution. So for example, this same equation, y is equal to 2x plus 6, if they give us the point 2, 3, we would graph this line and we would see that 2, 3 is not on the line, therefore it would not be a solution. So it would not be included in the solution set. Just remember that when you can find a solution set by substituting your x coordinate into x of the equation and your y coordinate to y of the equation, and seeing if it satisfies that equation, and if it does, then it is a solution to the problem. Here's an example. 2x plus 3y is equal to 18, and they want us to figure out if 3 comma 4 is the solution to the equation. Well, all we have to do is remember that 3 is the x, 4 is the y. We plug in 3 everywhere there's an x, plug in 4 everywhere there's a y, and we work our problem. So we go and plug it in. 2 times 3 plus 3 times 4, that's 6 plus 12. Is that equal to 18? Yep, sure is. Because the solution is true, because this works, and it's a valid statement, we do say that 3 comma 4 is the solution to this equation. Next, they're asking us to find solutions to the equation. They're asking us if they give us this equation, y is equal to 3x plus 1, to find 5 solutions to the equation. Pretty much all that's asking us is to find 5 points on this line, and we can do that pretty easy. We can arbitrarily pick points on this line as far as at least one of the points, and what they do here is they say, okay, we have this line, let's go ahead and say we know it's going to cross x equals -2 somewhere. What is the value of y at that point? So all that you do is say, okay, x equals -2. Everywhere you see a -2, or everywhere you see an x, I'm sorry, you put -2. So 3 times -2 plus 1, we know that equals -5. So our ordered pair becomes -2, which is what we said x was going to be, and we solved for y -5. Same thing right here. We say, let's say x is equal to -1. What does y equal? We solve it, we get y is equal to -2. So our ordered pair becomes -1 comma -2. Here we say, okay, if x is equal to 0, if it crosses x equal to 0, or when it crosses x equal to 0, what does the y equal? Well, we'll find out y is equal to 1, so our ordered pair becomes 0 comma 1. And we do this for all the examples they list there. Now they give us the equation 2x plus 3y is equal to 18, and they want us to determine if the ordered pair 3, 4 is a solution to the equation. Well, I substitute 3 in for x and 4 in for y, and actually we just did that one. And we see that indeed 18 is equal to 18, so it is a solution to the problem. So from this example, we found 5 ordered pairs. The way we can use graphs is we just plot those points on the graph, and you see that after we've plotted the points, you can later say, hey, that looks like a line, so you can draw a line straight through those points. And what the line means again is every single point that this line crosses is actually a solution to the problem. So that's all lines mean, is the lines satisfy the equation. So let's try to see if graph can actually tell something about problems, and this is where it gets really helpful. Graphs in a rectangular coordinate system can be very useful in telling a story. Try to select the graph that best illustrates the story of the population of the United States. Well, we know as the United States has grown, we have definitely increased our population, and it's really increased the past few years. So we see this as years down here. As years go by in this population, this one goes increase, but then it decreases. I don't remember ever hearing about a decrease in population in the United States, so this one doesn't work. This guy looks like it's going up, then back down. Well, I don't remember seeing any decreases in the United States population. This guy, it's growing slowly, and then it's growing fast, the population. See, the population is really high as the years go on. So this is more, to me, the most likely candidate, and sure enough, that's the answer. Definition of a linear equation is when you have one variable, ax plus b, where a and b are real numbers, and a is not equal to 0. We'll get more into this a little bit in the next lesson. And the graph of y is equal to mx plus b, this is going to be your standard y-intercept equation. Go ahead and get used to it, as we got plenty more on lines in this chapter.